All right, so many of us have put applause icons up, and I think we're ready to move on to Bill.
Okay, I've got two presentations. Do I do them back to back? Is that the plan?
Plan is too strong a word, Bill. Yes, that would be great. Do them in whatever order you wish. If you want to defer till after Sam is done for the second one, whatever your preference, we're flexible.
So Dennis has a presentation also?
Yes.
Good, we'll alternate
Not
that.
me.
There's no sensory overload, so I'll do
Sam has a presentation.
Sam, yes.
Sam.
Okay. Okay,
You're two are interchangeable. All Sam needs is a good beard.
Okay, I'll do the short one first, then Sam, and then I'll finish with the long one at the end.
It all seems plausible. Go with it. But first, tell everybody who you are.
Okay, and parenthetically, while the thought comes to mind, I want to compliment Dr. Ting for correctly spelling Figforth. The correct spelling is small f-I-g, capital F-O-R-T-H. And you see it in print every other way, but he has it the original way. Okay, and see, let me move around to screen.
Is it 2 words, Bill?
No, it's one word.
Uber. Well, actually hyphenated. It's small f-I-g hyphen capital F-O-R-T-H. That's coach me now. Have we got the first splash screen up?
I can see it.
Yeah.
Let me try to get. Try to get rid of that thing up at the top. Does anybody remember how to get rid of the black bar up at the top of the screen? It's a funny combination. Let me see if I can do it here. Hide video panel.
We don't have it here on our screens.
Looks good for us.
There we go. All right, now we're in business. So, gentlemen, thank you. Oh, by way of introduction, Bill Ragsdale. I was one of the 5 founders of the Fourth Interest Group in about 1978. We founded it at the coffee shop under an oak tree at Stanford after a homebrew computer club meeting. And we grew it to some 30 some chapters and about 3,000 members, and the rest is history. Oh, I wrote the Figforth model. And I also invented the words only and also. So other than those contributions. So now we're going to have a kind of a learning cute application. Somehow it popped into my head. I'm not sure how it occurred, but it was to generate an Uber driver time log. So imagine that you're driving for Uber and you have a little handheld cell phone, whatever, and you would like to have a log of your time. So simply time log for minutes worked. And it would look something like this. Here's a calendar, Monday through Sunday. Notice this is on the business style calendar where Monday is the first day of the week because it's the start of the work week. Sunday is the day of rest. So from the input for the driver, the inputs are fairly simple. The first is it has to reset to a new month. They have to say what today's date is, add some minutes today, and display a report. So that's about it. It's a nice closed form problem. And it has 4 fourth commands. As you can imagine, they're words: new month, today's date, minutes driven, and report. Now, I will put the one caveat on this, that I have not incorporated error checking for the operator's input. It's really very important that operator input is checked for a wide variety of difficulties and are they corrected or coped with. The words within the program are assumed to be error-free, and you don't need to do error checking word to word. But when you do a user interface, error checking is quite important. So how do we start? Well, we need an array of memory cells equivalent to a month. Number of days in a month would be the number of memory cells, 1 cell per day. So in this case, we declare a constant of 31, which is days per month. And again, it is very important to make the fourth words meaningful. We can have long names, somewhere between 31 letters and 256. So make the names long and descriptive. Then if you need a short version, do a pseudonym, rename it, add a new name with a very short one if that's more convenient. But for descriptive use, day after day, year after year, long names. The second constant is the number of days in the week, which is 7. And now we create a data array. That's done by using days per month, which gives a 31, and then the fourth word allot, which allots that many memory cells. So we now have a data array that holds 31 values. To clear that, we define a word new month. We specify data array, and again, days per month, and then the fourth word allot. Fourth word erase. So allot allocates memory and erases memory. And our checking, here's our testing. Very important. Whenever you develop a new word, write a little test routine for it. So in this case, we just type in data array, days per month, and dump. Dump takes the address and the quantity and displays that many memory cells. So here we see the hex address and then the empty memory cells and the ever popular OK. Let's take a look at what's in our month display. So now we develop a word test 1 with 2 do loops. The first do loop works over weeks. The second do loop works over days. So if you write it properly, you should be able to read it pretty well. So this says on the weeks per calendar, do over the weeks, days per week, also do. And then J selects the number of the week, compute days per week, I times I plus cells. This addresses into the data array. From the data array, we fetch, and then 4.r prints it out. So here's our first cut at a month display. We see over, in this case, 6 weeks, over 7-day weeks, print our memory area, which is currently empty. Now let's make it look realistic. So the first thing we need is a header. So the header will be a dot quote print. So dot quote prints Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and then the closing quotes. And we'll check the header. Again, every time you write a word, write a little bit of check routine, put it right in the source code. Dot header prints the header, and we see we've got Monday through Sunday. Now let's make it a little more a realistic month display. We'll do a word called report. And this is how it is structured. The D chart says over 6 weeks, over 7 days, show the date, go to the next day. And here is our month display. And you see the days go from 1 to 35 because we've actually got defined it more than over the 31 days. So too many days show. And more importantly, what if the first day is not Monday? So we need to make an adjustment to bring the first Monday into the proper day of the week. So we declare a value, first Monday, and it will hold the date of the first Monday. If it's the first day of the month, it will be 0. And this value is offset. It runs from 0 to 6. So where actually the actual Monday would be 1 through Monday would be 1 through 7. So we see that -1 offset. This day offset is a little bit complicated, and I won't dig into it too deeply because the logic is a little bit complicated. There's the offset. We make an adjustment for the first Monday. We go through that logic of swap days per week, first Monday, and so on to semicolon. And that will take the week and the day and add an offset to our calendar display. In this case, at the bottom, it's a test. So the first Monday adjustment, as I said, is a bit tricky. Just a simple test is if we put in a 1-1, the expected value is 4, which is what we get. Now we've expanded our D chart. So over 6 weeks, over 7 days, now we check, is it a valid day? If it's a valid day, show the date. That's the valid day, yes to the right, show the date. If it's not a valid day, we go to the left N and we just show blanks and then go to the next day and the next week over the entire month. So notice how we're incrementally expanding that report program, adding capability. And sure enough, it's now working. The adjusted calendar says, we see it says 5 is the first Monday and give us a report. And now we see the full month. And I've circled the first Monday, which is the 5th day of the month. And that valid range check now cuts our month off at 31. So there is the shell of an adjusted calendar. And now we're going to get ready to put some data in it. So here's the pseudocode of the entire program, which we've seen up till now. We've got the header, we've got over weeks and days. First, we make that Monday adjustment. Then after the Monday adjustment, we then show the day number, show the minutes worked, and then loop for the next day, the next line, the next week. And then finally at the end, we're going to show the total minutes for the month. And again, our D chart is fully expanded. We see at the top left over 6 weeks, over 7 days. We check the valid day. If the day is valid, we show the date and we show the minutes worked. Here's the full report. We won't go through all the logic of it. It matches that diagram we saw before. And the new added part is about 4 lines from the bottom. We're actually showing the where it says cells data array plus cfetch5.r 1 space. That is showing the actual time worked. So here we have the calendar, our header across the top, the days per week. In this case, Monday is set to be day 6. We have the 31 days, the adjustment for Monday, and then there's an empty column. You notice under each day, there is the day number, and then there is a 0, which is the column for the day's work. Now we need to enter the user information. So we already have, today we have a new month. Today's date built in the day number, and then now the new word is minutes driven. So if you put down, say 7 and then minutes driven, it will put an entry into the data array. Under minutes driven, it says today's cells data array plus store. It just increments data array by the minutes worked. Now we're getting there. Here's a sample driver input. The driver would type in new month. Then 6 is the first Monday. Then on day 5, he would type 5 today's date, which sets the day number. Then 40 minutes driven, makes an entry in the database. The next day on day 6, he would specify that's today's date. He would have 20 minutes driven and then 35 minutes driven. Finally, on day 7, he would have 25 minutes driven and 50 minutes driven. And on day 14, on day 14, you would have 240 minutes driven and then request a report. So that's the actual typed written driver input day by day. And here's the output that he sees. So if you go on the top row to Sunday the 5th, he worked 40 minutes. Under Monday the 6th, he worked 55 minutes. Under Tuesday the 7th, 75 minutes, and further down through the month. And at the very bottom in blue is the total minutes driven. So for the month, total minutes driven, 395. So what about the future? How to add? Seems like computer programs are never done. Well, the essential addition right now is to input error checks. That would be the range checks on the inputs. You can't put in days that are negative or days that are beyond 31 and so on. It would also be good to have printed reports. I foresee this right now as being on a little handheld where you see the numbers on the screen, but you'd not like to have a printed log. Really expanding it, this would just be a component in a bookkeeping system where you can then log your revenue and your expenses, and you can verify, are you getting the proper reimbursement from Uber? Finally, on a smartphone touchscreen, you add a lot of human factors, possibly graphical buttons and a keypad, and then finally spinners instead of a keypad. So now it would be fully user interactive, touchscreen, printed reports, everything. And as you can see, the core of the essence of the program is only about 15 or 20 lines of code. But when this is fully wrapped into a usable program, it would be hundreds and hundreds of lines of code to make it fully functional. For those who'd like to see it, go to my section on GitHub, Bill Ragsdale, and look under 4th projects, and you'll find Uber D, version D. And do we have any questions? We are speechless. Dr. Ting.
I mean,
Yes, go ahead, Dr. Ting.
okay. Bill, in the lessons to the JE 4th 6.13, I put in a calendar program, okay, and which would just do what you did, print out the monthly calendar. If you say, January, I think you should say 2021 April, and it will print out the current the calendar of the month. Okay, and it's I think you should look at it because it will calculate already what the first of the month, which day the first of month is. Okay? And it's interesting that all I need is the how many days in a year, and it's a big large floating number, and from that, and I think we know the January the 1st of 1950 is a Sunday. Okay, so from that information you can calculate all the days of month from there. Yeah, I think it should, if you can incorporate that, you don't have to ask the user to enter what day is the first of the month.
Yeah. Calendars are complicated. Generating calendars from nothing, from scratch, are very complicated. And so in your JE 4th, of course, you're able to draw on the resources built into the system itself, which is a real advantage. In this case, I was doing this totally from scratch where it's standalone program. But the real way, of course, then you would have to add which month of the year. This is generic in that it would work on any month of the year. And all the inconsistency would be that on something like February, where you only have 28 days, you're still going to see 31 days on the calendar because this is month insensitive. But like you said, use the resources available. If your language gives you calendars, use the calendars. Any other question? All right, I yield the floor back to Supreme Leader.
David,
Who the heck's that? Can you hear me now?
You're fine, yes.
Okay, great. Supreme, gosh, I think one of my favorite things about Meetup is that it gives you a title